All right, we're going to practice some inverse function problems now after being introduced today to inverses. And remember that the inverse is the opposite graph, or it is the line that is where all of the x and y values have been completely switched. Your domain becomes your range becomes your domain. So when we're graphing these, step one is going to be to draw a line of reflection, which is always going to be through y equals x. So we put a dot at the origin, go up 1, up 2, up 3, and back, etc. And then connect that with a dashed line and we titled that the LOR, the line of reflection of y equals x. Okay, so there's my starting point, my line of reflection. This inverse function is going to get completely flipped or reflected over that line of reflection. So I'm going to use green. So we're going to make a table. And this table is going to represent the coordinate pairs of your function versus the inverse, meaning once we flip. Okay, so let's see what I mean. You're going to go find some coordinate pairs of this original f of x. And by the way, we're going to label both graphs, so this one's my f of x. So let's go find a dot. I can see a dot here at back 1, 2, 3, 4, 5, down 1, 2, 3. -5, -3 is my first coordinate pair. And then I'm going to go find the next one down is this corner. So back 1, 2, 3, 4, down 1, 2, 3, 4, 5, back 4, down 5. Next one would be, I'm going to use this as a corner right here, you guys. It's supposed to be touching. It looks like it got slightly moved, but let's make that a corner, please. And so that's going to be out 1, down 1, 2, 3. And finally, let's use this corner right here of right 2, down 1, 2, 3, 4, 5, 6, 7. Okay, oops. Make that look like a -7. Now we take all these coordinate pairs, and for the inverse, we completely flip them. So -5, -3 becomes -3, -5. -5, -4 is my flipped, -3, 1 is my flipped, and -7, 2 is my flipped. So these are the new coordinate pairs of the inverse function. Let's go put them on the graph and make our inverse. So the first dot is -3, -5. The next dot is -5, -4. And what this is my new elbow. See how there's this line that's going off to that direction? This is going to be the new line going off in this other direction now. Okay, now we're going to go connect to the next dot, -3, 1. Sorry, -3, +1. So now we're going to go connect. We're making this little section right here over on this side. Okay, so this line here becomes this line here. And then finally, we want this little piece here. So go -7, 2. And that becomes our final piece of this inverse. So let's take a peek and see how is this the reverse. This segment here is like this segment here. Okay. This middle section here is like this new middle section here. That's the reflection of it. And then finally, this last piece here is your last piece here. So do you see how that kind of looks like? It's almost like it made a spider. And then this line of reflection goes smack down to where those two intersect in the middle. So that was our first practice on graphing one. Let's go try this next one as well, following the same steps. So draw the line of reflection, fill in the table for some coordinate pairs, and then let's flip them. Remember that our final step, label all lines, is to label this new inverse function, f of -1 of x. So make sure we label this new guy. Actually, I don't like this label being here. It looks too close. Let's maybe label it right here. Okay? Because this was my original function, and that's this line, it's too close to that. So let's put it over here on this green guy. All right, let's go try this one. 0, 0. I'm drawing in my line of reflection. I'm going to draw a dashed line. I want this function, this curve, to reflect across this. So it's going to land somewhere over here. Let's go make it. Now pause. You should be able to stop the video and try this problem and then check it. Okay, let's see how you did. So go grab some points. Out 1, up 1, 2, 3, 4, 5, 6. Back 1, up 1, 2, 3, 4, 5. Back 1, 2, 3, 4, up 3. And back 1, 2, 3, 4, 5, 6, down 2. Next, I'm going to flip these where all the x's are going to change with the y's. And let's go put these dots on the graph. This is going to be my new green inverse function. So I'm going to go to 6, 1. And that's the reflection of that dot right there. I'm going to go to 5, negative 1. I'm going to go to 3, negative 4. And I'm going to go to negative 2, negative 6. I'm going to do my best to connect this function. And there is my exact reflection over the line of reflection, y equals x. All right, so this is f of negative 1 of x, and this is my original function, f of x. How'd you do? Okay, so you have to be able to graph an inverse. Given an inverse, you have to be able to graph one. We also have to be able to work with them algebraically. Now, I showed you the switch x and y method, and right now I'm going to talk about the table method. This is what I think is kind of like a shortcut. So the original function, what's happening, and the inverse function, what's happening. So starting with this x value, what changes are being made to it? Step 1 is we're being multiplied by negative 4. Step 2 is that we're adding 1. What's the opposite of adding 1? What's the opposite of 4? So multiplying by negative 4 becomes multiplying by 1/4. So we're going to take this original equation. Our f of negative 1 of x is going to equal, we start with our x, we go in reverse order. First we minus 1, then we multiply by 1/4. And there's our function. Let's go do the next one. This time there's 3 things happening to the x. The first thing happening is it's cubed, or x to the power of 3. The second thing happening is it's multiplied by 2. And the third thing that's happening is there's adding 5. So I'm going to subtract 5. I'm going to multiply by a half, and then I'm going to cube root it. So let's go do these steps to our new x. First, we're going to minus 5. Then we're going to multiply by 1/2. Then we're going to cube root it. And there's our function. All right, let's go try this guy. First thing that's happening is it is being square rooted. The x is being square rooted, and then there's a 7 that's being minused. Opposite of 7 being minused is adding 7, and then opposite of rooting is squaring it. So here I go making my new x. And I'm going to first add 7, and then I'm going to square it. There's my function. Here's my next inverse. K of x, k of negative 1 of x. All right, so first the x is being multiplied by 7, then it's adding 10, then it's dividing by 2. So we're going to go times 7 plus 10, and then divided by 2. And over here, we're going to multiply by 2, then we're going to minus 10, and then we're going to times 1/7. So here I go, k, keep using an F, k of negative 1 of x. Start with that x, go in reverse order, multiply it by 2, then minus 10, then times 1/7. I'm going to rewrite this so it's a little bit clearer. I ran out of space. 1/7 times 2x minus 10. So again, this is the shortcut method. You're totally welcome to do the switch x and y method and see how it comes out. Okay, number 3, A and B. When given a group of ordered pairs like this, you're just going to flip it. So we're going to make this -3, 1, 3, -2, 1, 5, and 4, 6. You see what we just did reversing all of those? And then g -1 of x is going to become 7, -5, -8, -6, -2, 1, and 3, 10. Okay, how'd you do? I'm going to stop the video here and do a video for the back separately.